You are looking at the most expensive lock in your house, and it isn't on your front door. It is right here on your wall. Every modern programmable thermostat, from the cheap Honeywell on your apartment wall to the high-end Ecobee in your hallway, is currently running in consumer mode. It is a restricted version of the software designed to protect the HVAC company's service contract, not your bank account. But every single one of these has a hidden contractor mode. By holding two specific buttons for 5 seconds, you unlock the installer's setup menu. Inside are the specific calibration offsets and cycle limit values that your technician intentionally left at the factory defaults. I'm going to show you how to find your specific override code, how to widen your deadband without losing comfort, and how to stop your furnace from short cycling itself into an early grave. This takes 90 seconds, costs $0, and typically cuts a winter heating bill by 20 to 30%. The reason your thermostat is lying to you is simple. Comfort is subjective, but a service call is expensive. When an HVAC technician installs a unit, they want one thing: to never hear from you again. To ensure that, they leave the deadband or differential at the factory minimum, usually 1 degree. This means if you set your heat to 70, the second the air around the sensor hits 69.9, the furnace kicks on. It runs for 3 minutes, hits 70.1, and shuts off. This is called short cycling. It is the least efficient way to heat a home, and it is exactly how motors and igniters burn out. In contractor mode, we change that logic. Look at your thermostat right now. If you see the temperature flickering between 2 numbers every few minutes, you are losing money to a software limit. We are going to open the BIOS of your house. Before we touch the buttons, we have to talk about the wall gap. Most thermostats are mounted over a hole in the drywall where the wires come through. That hole is a direct straw to the uninsulated air inside your walls. Your thermostat thinks your house is 66 degrees because it is breathing 66-degree air from the wall cavity, even if the room is at perfect 70. The furnace keeps running because the sensor is being lied to by a physical draft. We are going to fix that gap with a piece of plumber's putty or even a bit of masking tape behind the mounting plate, then use the temperature offset in the hidden menu to sync the sensor to reality. Wait, don't touch those buttons yet until you hear about the anticipator ghost. In the old days, thermostats had a literal sliding wire called an anticipator that used electrical resistance to guess when the room would be warm. Modern digital units use an algorithm to do the same thing, but if your contractor didn't calibrate it for the specific length of your ductwork, your furnace is shutting off before the heat actually reaches the furthest bedroom. You won't find the access codes for these menus in the user manual. They are buried in the installer guide, which the technician usually throws in the trash or takes with them. For Honeywell units, the code is often a 4-digit number, specifically the 4 digits found on the back of the device's housing or a specific date code. For Nest, you have to navigate through the equipment settings to find the Pro menu. For Ecobee, it involves holding the menu icon until the installer options appear. Once you're in, you will see a screen that looks like it belongs in the 1980s. Do not panic. You're only looking for 3 specific numbers. Now, at this point, you might be worried about breaking your furnace. You aren't. We aren't touching the gas pressure, the voltage, or the fan speed. We are just changing the instructions the thermostat sends. And stay with me, because this next part is where the actual savings happen. If you have ever wondered why your heat feels dry or why one room is always colder than the others, it is because of a setting called cycles per hour, or CPH. Most contractors leave this at 5 for gas furnaces. That is a mistake that is costing you $50 a month. The physics here is undeniable. A gas furnace is like a car engine. It is least efficient during the first 5 minutes of operation because the heat exchanger has to warm up before it can start transferring energy to the air. If your CPH is set to 5, your furnace is turning on and off 5 times every hour. That means it is spending 25 minutes just getting up to temperature. For a high-efficiency gas furnace, you want this at 3, or even 2. This allows the heat exchanger to reach its peak thermal efficiency and stay there. Your furnace will run half as often for twice as long. You won't feel the temperature swing, but your gas meter will certainly see the difference. There's a second hidden setting in that menu called the second stage timer. If you have a 2-stage furnace, the thermostat is often programmed to upshift to high heat mode if the goal temperature isn't reached in 10 minutes. This is like flooring the gas pedal to get to a red light. We are going to push that timer back to 20 or 30 minutes. This forces the furnace to stay in its low gear, high efficiency mode for longer, which is much cheaper and provides a more consistent, gentle warmth. This next setting is the insurance policy for your air conditioner. Inside that contractor menu is a value called compressor minimum off time. In the summer, if there's a flicker in your power or a quick thermostat adjustment, Your AC compressor can try to restart while the refrigerant is still under high pressure. This is called slugging a compressor. It is the leading cause of compressor failure, and it results in a $4,000 replacement bill. Most factory settings have this at 0 or 1 minute to prevent "I'm hot" complaints. You're going to move it to 5 minutes. It is a set and forget insurance policy that effectively extends the life of your AC unit by several years. There is one final value that most people miss, and it is the fan-off delay. When the flame in your furnace goes out, there is still about $5 worth of free heat sitting in the metal heat exchanger and the primary ductwork. Standard settings shut the fan off almost immediately. By changing the fan-off delay to 90 or 120 seconds, you are harvesting that residual heat and pushing it into your living room. You have already paid for that energy. You might as well use it. If you have a heat pump, the contractor mode is even more critical because of the auxiliary heat lockout. Most heat pumps are programmed to turn on the expensive emergency electric heat strips if the outside temperature drops below 40 degrees. In reality, most modern heat pumps can still pull heat from the air down to 25 or 30 degrees. By lowering that lockout temperature in the hidden menu, you prevent the thermostat from turning on the toaster coils in your furnace, which can save you hundreds of dollars in a single cold snap. The wildest part about this is that once you have tuned these values, you will notice the vibration of your house changes. No more constant clicking of relays, no more sudden blasts of hot air followed by immediate silence. It is a more perennial, steady kind of warmth. You have taken a device that was programmed to serve the installer's convenience and forced it to serve your house's specific thermal envelope. You're no longer running on a generic factory profile. You're running on a custom-tuned energy profile that reflects how your specific home holds heat. This is the BIOS of your home's comfort. By reclaiming access to these settings, you are effectively opting out of a system designed for good enough and moving into one designed for maximum efficiency. It is a 90-second fix that pays a dividend every single month for the rest of the time you live in that house. If you have made it this far, you are clearly someone who cares about how things actually work under the hood. If you found your code and managed to unlock your thermostat, do me a favor. Hit the like button and share this with someone who is tired of paying a comfort tax to their utility company. Take care, and I will see you in the next one.